Bonjour, welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to join us live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View Channel 972. You're always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 2 until 3 in the afternoon, and we are in our 7th week of our 9-week course. You definitely should know what to submit at this point for marking, but as always to remind you, the support questions are practice problems and do not to be handed in. They have a little pencil icon to indicate them. And these are just to make sure that you are feeling confident understanding the material. You can decide which ones and how many to do. If you're understanding a concept, it's totally fine to skip over questions. You don't need to spend time on something that you already are confident with. If you need more practice, please feel free to reach out and I'm happy to send you more practice. The answers are in the back of your booklets, so please check your work as this will set you up for the most success to make sure you're actually on the right track. Now the key questions, the ones with a little key icon, these are the ones to submit for marking. So please do all of these questions, showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand. And if you're making any errors, I can help you figure that out. Okay, so how do you actually submit your work for marking? There's 3 methods. The first is to scan your work and send it electronically. You can scan your completed work using a device. If you have an Apple device, the Notes app has a scan function. And if you have an Android device, the Google Drive app has a scan function. If you're not sure how to use these apps, I have tech tutorials on my YouTube channel, which you can watch, and it walks you through step by step how to use these apps to scan. They're free apps to download if you don't already have it. They're really easy to use, and I can answer questions if you need extra help. Then once you have it as a file, you can send it to me through email at studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send it through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to send their work in through the fax if that's something you have access to. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So you can friend me on Facebook or subscribe to my YouTube channel, and you'll get notifications every time I upload one of our videos. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after airing. There's also short videos on my YouTube channel that explain common errors and confusing concepts. So this is a really good place to go and check out if you're struggling with something. Math is a really visual subject, so I strongly encourage you to access the video as opposed to just listening to the audio. If you can't join me live or access the YouTube videos, let me know. I'm happy to send you a copy of the recordings so that you can get the full experience. So if you have any questions or concerns, please reach out and connect with me. You can email me at bronwyn.slate@nnec.on.ca. You can Facebook me at B. Slate Wahsa. Give me a call at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m. though I teach the last hour of my day, so that is not a good time to try to get a hold of me. All right, we are continuing with lesson 17 today. In our last lesson, we talked about measures of central tendency, and today we're going to be focusing on standard deviation and a few other elements that take us a little bit beyond just knowing averages. So our learning goals for these lessons are that you'll be able to distinguish between the mean, median, and mode averages, and you will understand the purpose of the range, variance, and standard deviation for a set of data. So we focused on that first learning goal in our previous lesson, and this second learning goal is what we're going to be focusing on today. Our success criteria are that you can calculate the mean, median, and mode averages. Hopefully you're able to do that from our previous lesson, the first part of lesson 17. If you can't do that, then you need to go back and watch lesson 17 again. Part 1 again on YouTube and check that out, as doing the second criteria, being able to calculate the range, variance, and standard deviation is not going to make sense, and you're not going to have all the tools that you need in order to complete this. So you need to do that first piece first. Okay, but let's first activate our brain with some mental math. I don't believe in mad math minutes. They cause stress and anxiety in students and don't actually build skills. They focus on rote memorization and speed, which are not the focus of math education, or at least shouldn't be. So instead, we develop strategies that we can use in various situations that are based on our confidence and comfort with numbers. So our question today is 143 plus 168, and we are going to use the concept of near doubles. So these might not look like they are doubles because they really aren't, but both of these numbers are close to 150. So if I add 7 to 143, I get 150. And if I subtract 18 from 168, I get 150. Well, 150 plus 150 reminds me of 15 plus 15, which is 30. So that would be, 150 plus 150 would be 300. And I had to move one of my numbers up 7 and my other number down 18 in order to get to this balance. So I can think of, well, that means I have an extra 7 in one place and not enough. I have 18, not enough in the other place. So if I think about 7, take away 18, that means that I'm short. That means I'm short 11, because 7 take away 18 is negative 11. So that means that this really should be 143 plus 168 is going to be 311. Because when I was getting close to the near doubles, that's how I had to adjust it. So you can use near doubles even when your numbers are not as close to near doubles as you might like, but it can be a good tool to help you on your way. All right, mine's on. We are just going to do a quick review of measures of central tendency. Again, this is what was in the first part of lesson 17. So if you haven't watched that first video, go back and check that out. I will link it in the show notes of this video so you can find it easily. But just to remind us, if you did do that and you were comfortable with it, but just to remember, your mean, so these are all different types of averages of information of data. So your mean is when you add up all the data points and you divide by the total number of data points. This is probably one of the more common ones that we use in school often. The median is you have to order your data points from lowest to highest. and you have to find the middle value. So your median is your middle amount. And if you have two middle values, you have two numbers because you have an even number of data points, then you add those two numbers up and divide it by 2 to figure out what's the middle between those two numbers. And then your mode is the most frequent value. So it is possible to have more than one mode. You really just need to look to see which number happens most often. And if you have two numbers that happen most often but are the same number of times, then you might have two modes. Okay, so then what are we learning new today? We're looking at measures of variability today. So we looked at measures of central tendency yesterday. So finding that average, that middle piece of information that sort of gives us a ballpark idea of what our data is talking about. And then measures of variability is how much that information varies. So we're going to talk about first why variability is important. So we often focus on the mean to summarize the center of a population or a process. This is our mean is usually what we talk about most often with when we're talking about averages. And this gives us a center information about our data. But while that is important, it also matters how much data varies to understand what's going on in that situation. So a lower variability means that it's a more consistent data set. Most of the data is close to that mean or that average, and therefore there's not a lot of variability. Things don't vary too much. A high variability means that the data points are more dissimilar, and extreme values are more likely because everything is spread out and you don't have as much clustered around your average. So understanding your variability helps you to grasp the likelihood of usual events. So not only does your average tell you that this is what's most likely going to happen, but the variability tells you how likely that most likely thing is going to happen, if that makes any sense. So we're going to look at 3 different types of variability. The first one we're going to look at is range, and this is on page 10 of your IL booklet. So your range is the spread of your data from the lowest to the highest value in the distribution. So how you figure this out is that you subtract the lowest value from the highest value, the smallest number from the biggest number, and this will tell you your range. So for example, what is the age range of students registered in MBF3C in our course? So here I have all of my data. I have all of the age of people registered in the course. So 21, 36, 31, 26, 20, 25, 34, 22, 28, 27, 47. Those are the ages of the students in our course. And so the range is 47 is our highest. Take away 20, it's our lowest. So our range is 27 years. So the ages of our students in our course range by 27 years. So we might sort of look at that and be like, oh, most people are in their 20s or 30s. And so this range of 27 tells us really how that there's quite a large range in terms of ages of folks who are in our course. So people are really experiencing different things in life, most likely. So it is a good representation of variation if you don't have any extreme values. If you don't have any outliers or anything that's really, really different. But if you do, then that can really skew your information because you only use 2 points. So if one of your values is really, really high or one of your values is really, really low, then it's going to change all of your information. So looking at our example again, so what age range of students is registered in MBF3C? So our first group, our first 2, 4, 6, 8, 10 data points are all pretty similar. And then we have this 47, which is an outlier, which is fairly different than most of the other values. So that sort of changes that, makes our range a lot larger than possibly it would be. So it distorts our understanding of the age of our students in our course. So here, looking at this diagram, we have the same range for these two collections of data. So we're calculating here, it says range is equal to 150 take away 30, which is 120, because 150 is our highest value and 30 is our lowest value. But everything between 150 and 30 has 1 point, right? So this diagram shows us that there's one value in each of those points between there. Whereas in the second diagram, we have a range again of 150 take away 30, which is 120, because we have a highest value at 1 at 150, and we have a lowest value of 1 at 30. So those both count. But most of our information is at 50. So we have 9 points at 50. So though our range is the same in these two things, because our information is distributed in different ways, that isn't really helpful for us, because we have such a large outlier, such a large, all of our information is clustered, most of our information is clustered in one place, with a couple that are far away in the second example, whereas this first example, all of our information is evenly distributed. Everything's the same, so that range makes more sense. Okay, so that's why range, though it is really easy to calculate, isn't always the most useful way of understanding variance. So what is more precise? So variance and standard deviation are two types of an absolute measure of variability, and they can be confusing. So they describe, again, how the data is spread out around the mean. So that's similar to range, kind of. The similarities between variance and standard deviation are that they're both always positive. If the data points are identical, then the standard deviation and variance will both be 0, because there's no standard deviation or no variance, there's no variability if everything's the same. The differences are, between these two, is that variance means how far the numbers are spread compared to the mean average, whereas the standard deviation is a measure of dispersion of the data values from the mean. So those sort of sound very similar, and this can be really confusing, but we're gonna work through it, and hopefully with some practice, it'll make more sense as how these are different and how they're useful. So we're gonna look at variance first, and this is on, again, page 10 of your IL booklet. So variance measures how far data points are spread out from the set of data from the average. The mean is what what we use when we say the average in this case, the variance. So it's a numerical value that describes the variability of observations from its arithmetic mean. That is just the same thing said in a slightly different way to see if that makes more sense to you. It helps to determine the size of the data spread, and it's expressed in larger units than the data. So it's expressed in squared units, which sometimes can be confusing because it's going to be very different than what your data points are. The notation of it is called sigma squared. Sigma is a Greek letter that looks like a whistle from the side, or it looks like an O with a straight line sticking out of the top of the O pointing in the right direction. Or also you can represent it as S squared if you don't want to write sigma. Okay, so how do we actually solve for variance? Both variance and standard deviation have a bunch of steps to do in order to make it make sense. So we're going to figure out, for example, what the variance of our student ages in our MBF3C course are. So we're going to calculate the mean of the data. This is our first step. So that means that we add up all of our data points and we divide by the total number of data points. So 21 plus 36 plus 31 plus 26 plus 20 plus 25 plus 34 plus 22 plus 28 plus 27 plus 47, all divided by, once you add them up, all divided by 11. So our mean, which we can note, which the notation for the mean is x with a straight line on top of the x, is equal to 28.8. So the mean age of our students in our class is 28.8. That's the first step. The second step is to calculate the difference between each data point to the mean. So what this means is that we're going to, I like to do this in a chart to keep myself organized. I like to keep myself organized. And so I have all of my ages listed. And now I have the mean, which is 28.8. And to figure out the difference from the mean means that I'm subtracting the mean from the age. So how far away this age is from the mean. So 21 take away 28.8 is equal to negative 7.8 because it is negative, it's 7.8 years lower than the mean. 36 is the age, so 36 take away 28.8 is equal to 7.2 because it is 7.2 years higher than the mean. 31 minus 28.8 is 2.2. 26 minus 28.8 is negative 2.8. 20 minus 28.8 is equal to negative 8.8. 25 take away negative 8.8 is equal to negative 3.8. 34 take away 28.8 is equal to 5.2. 22 take away 28.8 is equal to negative 6.8. 28 take away 28.8 is equal to negative 0.8. 27 take away 28.8 is equal to negative 1.8. And 47 take away 28.8 is equal to 18.2. So again, you can use this method to organize your information. You do not have to, but this just makes it really clear what it is that I'm doing. All right, so then step 3. Now we're going to square each difference. So we figured out what the mean was, and now, sorry, the difference from the mean, how far away it is from the mean we are, and we're going to square each of those numbers. So that means that for age 21, we're negative 7.8 years away from the mean. We're going to square that, which is 60.84. And then we're going to just continue. 7.2 squared equals 51.84. 2.2 squared is 4.84. Negative 2.8 squared is equal to 7.84. So you can see our negative values now become positive because we're squaring them. Negative 8.8 squared is 77.44. Negative 3.8 squared is equal to 14.44. 5.2 squared is equal to 27.04. Negative 6.8 squared is equal to 46.24. Negative 0.8 squared is equal to 0.64. 1.8 squared is equal to 3.24. 18.2 squared is equal to 331.24. Sorry, 24. So that is step 3, is we're squaring the difference. And then step 4 is to find the sum of the squares. So now we're going to add up all of those numbers that we just found when we're doing the squares. So all of those values added up is equal to 625.64. And then finally, we're going to divide the sum by the number of data points minus 1. So the variance is equal to 625.64 divided by 11 take away 1. And so that's 62.564 is what your variance is equal to. So there are a lot of steps They can be awkward. It's easy to make mistakes because there's a lot of data information that you're organizing. So figuring out a system that works for you is really important. Screenshotting this screen right here where I have the 5 steps listed, although I don't have all the examples, I have some of the work shown, like the results opposed to the individual steps. But this could be really helpful to help you remember. You do not need to, while you're working, you don't need to have it memorized, but understanding what your steps are that you need to do is really important for calculating your variance. Because it's easy to just miss one little thing. Like it's easy to forget that you have to subtract 1 every time. When you're dividing, you have to do the number of data points, take away 1 less the number of data points. So just having a reminder might be really useful while you're practicing. So here is showing you how your data points, sorry, I might sneeze. Sorry, excuse me. So you can see here how you potentially have similar means for these 2 collections of data, but then you can see that they are spread out more differently. So your variance would indicate that. In this first example, we can see that some people benefit greatly, some people are of high amount, and others do not. Other people have a really low amount. Whereas here, so this is a high variance, you're going to have a high value because your information is really, it varies a lot. There's a wide spread. Whereas here we have consistent benefit in this bottom graph because most of our information is closer, it's clustered around the mean. And so this has a low variance. All right, so the next one that we're going to do is standard deviation. And again, page 10 of your IEL booklet. So the standard deviation, or the standard or typical amount of data that points deviate or differ from the mean, is what standard deviation means. So it measures how much data points differ from the mean of the data set. The measure of the dispersion of data points relative to their mean. These are all different ways of saying the same thing. This is one of those ones that is really confusing for folks. So I thought I would give a few different ways of saying the same thing because it might click. And the standard deviation to calculate it is the square root of the variance. So this means that it's expressed in the same units as the original values. So it's in minutes or meters, opposed to minutes squared or meters squared. So this sometimes feels like it's more useful because it's comparing to a number that it's relating to the numbers that we're already looking at. So the notation for it is sigma or just S, opposed to sigma squared, which is variance. Okay, so how do we solve for the standard deviation? So again, looking at what is the standard deviation for our student ages in our class. So first we need to calculate the variance. We need to go through those 5 steps to calculate the variance that we just practiced. So we remember we figured out the variance was 62.564. So to do the standard deviation, there's no shortcut. You have to figure out the variance first by doing all of those steps. Then step 2, we square root the variance. So that's going to be a button on your calculator that you're going to press. So standard deviation is equal to the square root of 62.564, which is 7.8 or approximately 8 years for this situation. So what that's telling us is that everybody's age is about 8 years from our mean age in terms of how big of a spread of our data is for our ages in our class. So here looking at a graph that shows some standard deviations, comparing them. So this is job satisfaction ratings. So how happy people are with their jobs. They all have the same average. all of them have about a job satisfaction rating of 50, between 0 and 100. So you can be like, okay, everybody, all these jobs are basically the same. Everybody's basically happy to the same amount. But looking at our standard deviation, if we have a standard deviation of 5, that means that most people fit within 5 points, either above or below 50. So that means that most people are satisfied with their job on a rating between 45 and 55. So that's pretty good. If our average is 50, most people are clustered around that. Whereas if we look at our standard deviation of this green line, which is 20, which means that our job satisfaction is everybody fits within, or most people fit within a amount between 20 points from the median, or sorry, the mean, which means that it's down to like 30 or up to 70. And so people feeling about your job between 30 and 70 is a really, really big difference than people feeling this similar about the job, how good they feel about the job between 45 and 55. So that standard deviation gives us more information about how, though the averages are the same, that just tells us a lot more information about how much the information is spread out and what that gives us more details. All right, so now you can do the support questions on page 11, question number 5. But let's do some more practice to figure out how this is actually useful. So number 1, Carmela's monthly gasoline expenses in dollars for the past year are shown: 61, 83, 77, 88, 67, 71, 65, 72, 67, 40, 84, 90, 80. That's how much she spent on gas each month. So we need to calculate the range to the nearest dollar. So remember, range is our highest value, take away our lowest value to just see how much is spread out. So we look, so right now 61 is our lowest, and you just look through your information, and I don't have anything lower than 61, and 90 is my highest. So my range is going to be 90, take away 61. Well, 90 take away 60 would be 30. So 90 take away 61 is going to be 29. So Carmela's gas ranged in by $29 over the course of the year. So B, calculate the variance to the nearest dollar. So remember so first we have to figure out the mean. And this is why having an organizational system is really useful. So I'm writing plus signs in between my list of information to save space instead of writing them all out. And then I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Right, 12 months. I should have known that. Sorry. Okay. So we have 61 plus 83 plus 77 plus 88 plus 67 plus 71 65 plus 72 plus 67 plus 84 plus 90 plus 80. All of that divided by 12 is equal to 75.4. When you're doing your average, generally it's useful to give yourself 1 decimal point, just because it's going to give you more details once you're squaring things, and then rounding off to the nearest dollar at the very end. Okay, so the mean is equal to 75.4. Okay, so then the next step, I'm going to erase my division. Again, developing a system that works best for you. Mine, it does not have to be the same as mine. So for each of these, we're going to find the difference between each points. I think I spelled that wrong. So anyway, so 61, oops, always good to clear your calculator. 61 take away 7.4 is equal to negative 14.4. $83 take away 75.4. Good if I wrote my numbers correctly. Is 7.6. $77 take away 75.4. You can totally do these in your head if that feels good for you. If it doesn't, do it on a calculator. 88 take away 75.4 is equal to 12.6. As you can see, it is time consuming. 67 take away 75.4 is equal to negative 8.4. 71 take away 75.4 is equal to negative 4.4. 65 take away 75.4 is equal to negative 10.4. 72 take away 75.4 is equal to negative 3.4. Negative 3.4, sorry. 67 take away 75.4 is equal to negative 8.4. $84 take away 75.4 is equal to 8.6. 90 take away 75.4 is equal to 14.6. And 80 take away 17.4 is going to be 4.6. Okay, so we did step 2. We squared the differences. Step 3 is to, sorry, we found the differences. Now we're going to square the differences. And I'm going to do this 2 steps in the same moment. We're going to square the distances and then we're going to add the squares. Just for the sake of time and to do my calculator. So I'm going to put in all of my values and I'm going to square them and then add them together. So you don't have to do it this way. You can just find all the squares first and add them all up. This is going to be a little bit faster for me to do it instead of writing them all down. So you figure out, again, what works for you. I know that I say that I want to see all your work, but sometimes it just isn't logical to do that. If it helps you to do it in that way, to write it all out, go for it. That's totally fine. As you can see on my calculator, it starts to get tricky. I'm putting the brackets in because if I don't put my brackets in on Desmos, then then it doesn't work. The negative doesn't apply it properly. So I need to be smarter than my calculator. Negative 3.4. I do really appreciate how Desmos keeps my information so that I can see where I make mistakes, because I do. So here it is harder to see because I have my screen smaller in order to have both my screens visible. But if I'm otherwise, it is great. And it's not happy. This has this little alert because I forgot to put my squared, so it was not satisfied that I gave them a proper number. Okay, so if we add all the squares, we get 1,014 and 92.92. So then the fifth is to divide by 12, take away 1. So to find our variance, we do 1,014.92 divided by 11 is equal to 92.3. So it said calculate the variance of the nearest dollar. So the variance is equal to $92. And it's like, what does that even mean? So then we're going to calculate the standard deviation. So remember, the standard deviation is equal to the square root of the variance. So the square root of the variance is equal to 9.6. Again, it wants to the nearest dollar, so $10. So that means that though the range was 29, in general, most of the time she's paid $10 away from above or below the mean. So the mean, which was 75.4. So generally she paid between $65.40 and $85.40 is what that means. Okay, number 2. A bowling team needs one more person. Eileen and Ingrid are being considered for the spot. They both have the same mean score, but Ingrid's scores have a lower standard deviation than Eileen's scores. Which person should be chosen and why? So this is a question that instead of having to do the calculations, we can just use logic. So they both have the same mean score. That means that they can't say that, oh, this one has a higher average than that one. They have the same. But Ingrid's score has a lower standard deviation, so it has a lower variance, a lower variability. Sorry, not a lower variance, a lower variability. So that means that she doesn't have as many highs and as many lows. She has more information. Her scores are closer to the mean. So I would choose Ingrid because she's more consistent. Consistent. Sorry if I spelled that wrong. My brain is just not with me today. Okay, that's why I would choose Ingrid. Number 3, calculate the range, variance, and standard deviation for the points scored at a home games for a basketball team. Awesome. So these practice problems are not fun because calculating variance is annoying. Okay, so the range, our lowest we have 100, 105, 101, 103, 100, 99, 102, and 98. So 98 is our lowest and 105 is our highest. So for our range, we have 105, take away 98, which is 7 points. So the range is 7 points for the scores at home games. So then the variance. So as you can see, if you do some practice problems and you're getting it and you're having no problems and you're like, I just can't do the variance anymore, then it is fine to to skip. You decide what's best for you. So we have 1, 2, 3, 4, 5, 6, 7, 8, 8 numbers. So for the mean, we are going to add our numbers together. 100 plus 105 plus 108 plus 103 plus 100 plus 99 plus 102 plus 98 is equal to 808. So 808 divided by 8 is going to be 101. So the mean point scored is 101. So then the second step in the variance, we found the mean, is now we need to find the distance between each points and our mean, which is 101. So the difference between 100 and 101 is -1. Between 105 and 101 is 4. Between 101 and 101 is 0. Between 103 and 101 is 2. Between 100 and 101 is -1. Between 99 and 101 is -2. Between 102 and 101 is 1. And between 98 and 101 is -3. So then we could square them. Again, these numbers are a little bit more manageable. So 1 squared, -1 squared is 1. 4 squared is 16. 0 squared is 0. 2 squared is 4. -1 squared is 1. -4 squared is 4. Sorry, -2 squared is 4. 1 squared is 1. -3 squared is 9. So then we can add them all up. 1 plus 16 is 17. Plus 4 is going to be 21. Plus 1 is 22. Plus 4 is 26. Plus, well, 1 plus 9 is 10. So that's 36. So then our variance is 36 divided by 8, take away 1, which is 7. 36 divided by 7, I don't have in my head, is 5.1. So the variance is 5.1, and then the standard deviation is equal to the square root of 5.1, which is equal to 2.26, 2.3. So the standard deviation is 2.3. So the mean is 1.1, and most of the scores are within 2.3 points of that. And that's what the standard deviation means. So sometimes it's not so bad if your numbers are more friendly. Sometimes it can be a real pain. And again, you have to figure out a way to organize it to make sense for you so that your information is clear for yourself. My way might not be the clearest for you. Kind of have to follow along, and if I haven't labeled it super awesome. So figuring out a method for yourself is important. Number 4, Cole's math test scores have a mean of 81% and a standard deviation of 5%. Daya's scores have a mean of 84% with a standard deviation of 10%. Whose test scores are more consistent? So Cole has a lower mean of his math scores. So most of Cole's scores, so 81 is the middle, and they range from going up to 86 and down to 5 below 81 is 76. Daya has a mean of 84, so her mean is higher, but her deviation is bigger between 94 and 74. So Cole's test scores are more consistent. So as a teacher, this tells me that Cole has a fairly consistent understanding of the course material. So he doesn't have stuff that he really understands really, really well and stuff that he really doesn't understand at all. He's more even keel, whereas Daya understand some things really, really well, and then other things are fairly confused about, or sort of confused about. So that's just sort of helps you understand the standard deviation, helps us give us more information opposed to just their averages, which just tells us where the sort of middle is. All right, so let's consolidate what we've learned today. So again, we are looking at the standard deviation portion of lesson 17 today. So we looked at range, which is the difference between the lowest and highest values. And if we have outliers, this distorts the accuracy of our information. Then we looked at variance, which measures how far data points are spread out in the set of data compared to the mean. And it has squared units. And remember, it's calculated. This is the sentence that explains how it's calculated. It's the sum of the squares of data points distance from the mean divided by the number of data points minus 1. So that one sentence explains all those 5 steps. But if the 5 steps make sense to you and that sentence doesn't, that's fine. Then we looked at the standard deviation, which is the typical amount the data points differ from the mean. It has the same units as the original data, and it's the square root of the variance. For our purposes and your experience in high school or with high school credits, the standard deviation is what's going to be more useful. If for some reason you go on to study statistics further, I'm sure there's some sort of the variance makes sense to some folks and why it's useful. It's not something just that I have ever found to be super useful, except that it's how we get the standard deviation. Okay, so hopefully from our previous lesson, you can calculate the mean, median, and mode averages, and now you can calculate range, variance, and standard deviation. And that wraps up lesson 17. If you have any questions, always reach out and contact with me. This is like a calculation heavy lesson. So please reach out. You can call me at the office at 807-737-1488, extension 2209, or toll free at 1-800-667-3703. Send me an email at bronwyn.slate, which is spelled BRONWYN.SLATE@nnec.on.ca. Connect with me through Facebook at Wahsa. And remember, all of our lessons are up on YouTube. Under the channel is Wahsa, and the playlist is MBF3C. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.